Hello and welcome to my YouTube channel. My name is Neha Kukreti and today is the first lecture on one-dimension Dirac delta function. So, one-dimension Dirac delta function is defined as infinitely high and infinitesimally narrow spike whose area is 1. And this function is defined as its value is 0 for all the points which is not equal to 0, and at x equals to 0 it shows a value which is infinitely high, and therefore it forms such a spike, and its area under the curve is defined as 1. It's always 1. So if we integrate this Dirac delta function from minus infinity to plus infinity, we'll get the value 1. Now let us define a function fx, then its product fx delta x is equals to 0 everywhere except at x equals to 0. Okay, so we can write fx delta x is equals to f0 delta x, and therefore its integration from minus infinity to plus infinity will give us the value f0. That is, we'll just substitute the value x equals to 0 at the function given to us. Now let us shift the origin. So we define x minus x naught equals to 0 for x naught equals to x naught, and it give value infinite for x equals to x naught. So it will look like this is the function x minus x naught, and at point x equals to x naught we'll get a spike. So now let us understand this function more by solving some questions. So in this example we can see the function gives the value for x equals to 1. Also, we need to check whether this point lies within the limits. So x equals to 1 lies between 0 to 2. So we will get certain value for this integration. Now, after that, what we can do, we can use this formula. Okay, so we can directly substitute the value into the function and we'll get the result. So f1 here, fx is equals to x cube plus 3x plus 2. So my integration becomes 1 cube plus 3 1 plus 2, that is 6. This is the answer. Now let us proceed with the another example. Here the value of x is equals to 3. But as you can see, this value doesn't lie in this limit, integration limit. Therefore, its answer is simply equals to 0. So try solving this question and you can comment your answer below. So till now we have solved the Dirac delta function whose power was linear. We have solved the Dirac delta function for which the power of x was linear. Now what happens if the power becomes 2 or 3 and so on? So for power series we have another formula. Let's see what it is. Delta fx is equals to delta x minus xi mod f dash xi. So in this formula, xi's are the solution. Okay, this is the solution of fx is equals to 0. When we will put this function equal to 0, then we will get xi's. And one more thing, this f dash xi should not be equal to 0. Then only we can use this formula. Now let us try to understand how we're going to use this formula with the help of two previous year questions from JEST. So let us solve this question step by step. Okay. So step 1. In step 1, put fx is equals to 0. Here, this is our fx. So x square minus 3x plus 2 is equals to 0. And solve this equation. We will get minus 2x minus x plus 2 equals to 0. So x minus 2 minus 1 is minus 2 equal to 0. So we get xi equals to 1 and 2. Now let x1 equals to 1 and x2 equals to 2. So here we get our i's. Okay. Now step 2. In step 2, let us evaluate f dash xi. So what is fx? Fx is x square minus 3x plus 2. Now f dash x means differentiating the function fx with respect to x. So we get 2x minus 3. Okay. Now let us put the values. F dash 1 is equals to 2 minus 3 equals to minus 1 and f dash 2 is equals to 4 minus 3 equals to plus 1. Step 3. Write down delta fx in the given form. So how I can write delta? What is fx? X square minus 3x plus 2. So we can write it down as del x minus 1. Okay. Upon mod of f dash 1 plus delta x minus x2, that is 2, upon mod of f dash 2, that is plus 1. That is equals to delta x minus 1. And what is the value of mod minus 1? It is equals to 1. Same goes for plus 1. Plus delta x minus 2. So this is the result we get. So you know how mod is solved. Mod x is equals to x square root over. Okay. So when I say mod of minus 1 square root over, that is 1. And mod of plus 1 is equals to 1 square root, that is 1 also. Now for the last step, we need to solve for integration. Minus infinity to plus infinity, x square plus 1 del x minus 1 plus del x minus 2. So let us break this integration. X square plus 1 del x minus 1 dx plus minus infinity to plus infinity del x minus 2 is function x square plus 1 dx. So here we can see this delta function is converted into uh, linear power of x. Now we simply put the value of x equals to 1 at this function. So we get 1 square plus 1. And as for here, we have x equals to 2. Simply put this value here. So we get 2 square plus 1. So 1 plus 1 plus 4 plus 1. That is 7. So our correct answer is option D. Now let us solve another question from JEST 2019. So step 1, here this is the fx. So put fx equals to 0, that is x square minus pi square equals to 0, which gives us x equals to plus minus pi. These are our xi's. So x1 equals to minus pi and x2 is equals to plus pi. Now step 2. Let us evaluate f dash x. So f dash x is equals to 2x. So f dash minus pi will give us minus 2 pi and f dash pi equals to plus 2 pi. Step 3. You can write delta x square minus pi square as delta x minus pi upon f dash minus pi mod of f dash minus pi, that is minus 2 pi, plus delta x minus plus pi upon mod of 2 pi. So this will give us result 2 pi. So we can write it as 1 upon 2 pi del x minus minus becomes plus pi plus 1 upon 2 pi del x minus pi. Now the last step, fourth step. Here we'll evaluate the integral. So integration from minus infinity to plus infinity cos x delta x plus pi upon 2 pi plus delta x minus pi upon 2 pi dx. Let us break this integration into two parts. Cos x delta x plus pi, and we can write this outside the integration. Dx plus 1 by 2 pi minus infinity to plus infinity cos x delta x minus pi dx. So again it is converted into linear power. Now we can simply put x equals to minus pi into the function. So 1 upon 2 pi cos minus pi plus 1 upon 2 pi cos of pi. Here x equals to pi. Okay. Now, two important properties. Cos of minus x is equals to cos of x. Number one. Another one, what is the value of cos pi? Cos pi is equals to minus 1. With these two values, we can write 1 upon 2 pi. This becomes cos pi only. Okay. Why? Because cos minus x equals to cos x. Then cos pi is equals to minus 1 plus 1 upon 2 pi cos pi, that is minus 1. So we have 2 times of 1 upon 2 pi minus 1. That is simply minus 1 upon pi, which is the answer. In the next lecture, I'll discuss more previous year questions, and after that I will discuss 2-dimensional and 3-dimensional Dirac delta